Alright, time for another dryphysics.com video presentation. So the evil, Ian Gostling, and he's just evil. Below contempt. Really, beneath all standards of using a brain correctly. So I have gone over this and over this. I've actually drawn this, I think it would be fair to say, 200 times. 200 times I have illustrated a Galilean fact that he's rejecting. And it's a really, it's sort of a clever thing that Galileo did, right? He really couldn't just drop stuff and watch it fall and say which one hit the ground first and stuff. It doesn't really work because it ever moves too fast. So he figured out that if you let something roll down a ramp, it is illustrating the same effect, and it just does everything much slower because it takes longer. Yes, more gravity is affecting it, but it's all going into the ground, and you get the same consequence. And so what he discovered was this 1-3-5 rule, that in the first unit of time this falls 3 units of distance, and then in the last unit of time it falls this last little bit. And the same happens lifting off. And you can just understand it as how it accrues velocity. I didn't draw that wrong, did I? Anyway, yes, in the first unit of time it does this little distance. The second unit of time it gains the acceleration. Okay, it's the velocity. And so now it does this unit in the same time it did this one. Okay, been over it and over it and over it. So he rolled it down a ramp, found out this relationship, that this is 1 unit of distance in 1 unit of time, then there's 3 units of distance in the next 1 unit of time. Okay, 1 unit of time, and then 5. Okay, 1, 3, 5, and it just goes on and on forever. 7, all odd numbers. All right, and it's a big deal. Okay, and it does basically prove that gravity is a time-dependent force, but whatever. So he's rejecting this Galilean fact. All right, now I've pointed out that gravity could really just be understood that your mass is like a bucket, okay, and you're collecting gravity. So if you have a small bucket and you're in the rain, you won't collect as much rain as if you have a big bucket, right? But proportional to the size of your bucket, you will collect an amount that's going to be the same as a ratio, which means that's why you fall at the same rate, is because the small mass collects a small amount of force, the big mass collects a big amount of force because it takes more force to move big things and less force to move light things. That's why everything falls at the same rate. Not because they collect the same gravity or the same energy, it's because they collect energy proportional to their mass. So when the feather hits the ground, it doesn't go boom, it just goes bing. And when the hammer hits the ground, it goes boom, because it collected a whole bunch of force, because it has a whole bunch of bucket. So it caught a lot of wet or rain or snow or whatever, and that heavy stuff hits the ground and it creates a lot of action, where the feather collected nothing. It's a very tiny bucket, 2 drops of rain, poof, nothing. All right, very understandable, not complicated. A kid could do this. All right. A little tiny kid, maybe even a dog could understand it. Who knows? A smart pig. All right, but Ian Gostling, no. All right, so again, I'll draw it once more. So this is a simple way of doing it, right? You keep things simple. So if I make this a 1 velocity, I make this a 2 velocity. I keep the masses the same. The 1 velocity will go this 1 unit of distance in 1 unit of time. 1 distance, 1 time. All right. The second one, the one going twice as fast, is going to go 4 units of distance. Okay, but it's going to do it in 2 units of time. The first unit, because it's going fast, will be these 3. And the second unit will be just like this one. This is where it'll go 1/2 the velocity, 3/4 down the track. And then this will be identical to this. Okay, 1 velocity, 2 stop. And this will be the same amount of time. So this is 1 unit of time, 1 unit of time. So twice the velocity, it'll roll for twice the time, but it will roll 4 times the distance, because it'll go across the distance faster than this will. So it gets there sooner. Okay. So run it so many times. It's just an absolute fact. This is how the world works, and he wants to deny it. So Galileo discovered it 500 years ago. He's saying it's not true. It's not how it works. It's not what happens. When it's absolutely what happened. But what Galileo also observed was it didn't matter which way he put his ramp. If he put his ramp really steep, still 1, 3, 5. Put his ramp really flat, 1, 3, 5. Same thing. No, well, 1, 3, 5. And so Gostling now has said, okay, I'm going to try to break this simple logic that he's drawn 200 times by saying, oh, let's say he's going 10 times as fast. So let's just screw it up by changing it. Doesn't make that big a difference. Okay, so now we're not going to bother saying how far does the 10 times as fast thing go. We're just going to say, what's it do in 1 unit of time? Well, in 1 unit of time, you have to do the 1, 3, 5, 7, 9, 11, 13, 15, right? 1, 2, 3, 4, 5, 6, 7, 8. And then you have to go 17 and then 19. So you have to understand that that's what it's really going to do. Okay, all of those. Because it's a 10 velocity. All right. But we're just talking about the first unit of time. So this is a unit of time. Unit of time, unit of time, unit. So if this was 1 second, this is 1 second, this is 1 second, this is 1 second, this is 1 second, 1 second. It's going to travel for 10 seconds. That's all. Just 10. It's going 10 times faster. It'll be just 10 times, 10 seconds. But it's going to travel all of this distance. So it's going to travel a total of 100. But in the first second, it's going to do this. Unfortunate. It's going to do this 19. This 19 is going to happen in the first second. So this first second is going to be 19 units of distance. All right, 19 of these. And it's going to do it in the same time. The same 1 second, this will travel 19. So you can understand if these had the same size bucket, and this one went this one distance in 1 second, and the stuff was falling 3 per second, it would have 3 things in its bucket. Well, this is going to travel 19 units of distance, but it's going to travel them very fast, and it's still only going to get 3, because that's all it's going to be able to collect, because it's only going to be in the 19 in the same unit, the same amount of time. So yes, after 19 units of distance, it'll have 3 in its bucket. This will have 3 in its bucket. This will have 3 in its bucket, because it's the same amount of time. And then you go 17, 15, 13. You keep going, going, going until you get to that last little unit of distance where it's going 1 velocity, and that'll be just like this one again. And in that one little tiny distance, it'll collect 3. But it's only going to collect 3 in that first unit, because, and even though it went 19 units of distance, it's only got 3 things in its bucket because it went through the rain really fast. I shouldn't have to do this over and over. I've already done this. I've already explained this. He just keeps belligerently saying that there's something wrong here, but he won't point out exactly what I drew here that was wrong. That's incorrect. That's not a fact. I keep saying, draw what I draw, and then explain where what I draw is inaccurate. Show where, I said this is 3/4 of the distance. Show that that's not correct. That 3/4 of the distance is going 1/2 of the first velocity. So it's going 10v for this 19. And then after the 19, it's only going 9v. Well, where is it going 9.5v? Right here, 3/4 of the distance. That's where it's going 9.5v. This rule of Galileo's is always correct. Alright. Should be a law. Should have a name. But anyway, I don't get to write the should laws. So, I'll play this shit, but it's just shit. This is so Look at this stupid title. Draft Physics' Incredibly Poor Grasp of Reality. And I'm defending a 500-year-old Galilean theory that's never been disputed by a single physicist in the history of physics. There's no physicist who disagrees with Galileo's observations regarding the 1, 3, 5, 7 rule of gravity. None. Zero. There's no physicist on Earth who says that doesn't happen. The beginning I have to go to. So I did play the last bit, but I thought I would play the video without the sound on to start, just as I said, I can't believe he's going to make this same crappy argument again. All right, and I said, oh, it's impossible. So I played the half the video without the sound just to see what he draws, and I was just stunned because he's got miles per hour, then seconds. You know, it's all over the place, and you're just saying, why doesn't he stick to this simple diagram? Why does he have to do this to it? Seconds and miles per hour in the same drawing? Why do that?
I made that last video about the question for you. It was really to see, I was beginning to suspect that these complicated arguments,
such an idiot. He's an idiot. He's an idiot. He's an idiot.
Was pointless.
He's an idiot.
With you, because I was beginning to suspect
he's an idiot.
That we couldn't even agree on the fundamental basics of life.
Oh, duh. Fuck you. You figured that out just now? That's right. I'm arguing for things that really shouldn't have to be argued. Okay, it is beneath the planet of the flat earth. All right? You are beneath the flat earthers. All right? You're so fucking stupid. You keep making obvious and stupid errors and nobody corrects them for you except me, so you keep thinking you're still winning because some moron in your comments section says great video even though they don't know what the fuck you're talking about. I mean, you're a fucking idiot. You've made huge, giant, glaring mistakes, and you keep doubling down on them. You haven't learned anything. Again, he made a video where he said proof of blah blah blah, and then he realized, oh yeah, he can't figure out what 4 times the distance is. He couldn't accurately measure 4 times the distance. Fucking idiot. And he just keeps doing this arrogant, stupid mistakes. Stupid, moronic mistakes. And he just he keeps doing it.
Of what is. So I posed this question just to see. And the answer was clear that you couldn't see or wouldn't see.
So the answer is clear. Just watch the previous video, done very well, diagramming all of this stuff over and over and over again, pointing out how it really works. Did he refute any of it? No, he just discounts it. Okay, he doesn't want to hear the truth. He doesn't want to know the truth. And again, he hasn't researched any of this. He doesn't know shit about Leibniz. He doesn't know shit about Descartes. He doesn't know shit about how this whole theory was developed and got indoctrinated into physics. He just couldn't care less about the facts. He just wants to make a petty hate video, and that's all he's here for, is to jump on a petty hate bandwagon. He can't make a rational physics argument. He's just desperately trying to pretend his way out of what are these are Galilean facts. You can't refute these retards with your stupid drawings, no less.
And there was no agreement on very simple concepts. I've redrawn it here for you.
Yeah, it's the same silly, moronic, bad drawing. So again, he won't do what I have done 200 times. He won't draw the simple twice the velocity diagram and explain how the 1 to 3 thing doesn't happen. That's all that would solve the problem. He won't do it. Because he can't do it.
This now is a car. And we're going to say that it's moving at a velocity. The same as the bucket was moving at a velocity. No, I never said that the bucket was decelerating or accelerating.
We're talking about in gravity. It has to decelerate, you fucking idiot. We're not talking, if it was in space, then this argument would be a different argument because it would constantly keep going, whatever the double velocity it is. All right, and so for every unit of time, it would collect exactly the same. For every unit of time, it would go the same distance. So there wouldn't be an issue between distance and time. They would always be the same thing.
I said it was moving with a given velocity. So think of the car. If we say that the car's moving at 1 mile an hour, and this distance is 1 mile, if he's moving at 1 mile an hour, he's covered this distance in an hour, isn't he?
I don't know. Has he?
Velocity's not changing. If I now, I won't ask you whether you agree, but this is ramming the point home, actually.
It's not gonna. There's not gonna be any point rammed anywhere.
If we now say that we're going to increase the velocity of the car, so it's moving at 10 miles an hour.
So it has a constant velocity now of 10 miles an hour. So in every unit of time, it will go 10 times farther because it has a constant velocity. So he's eliminated the gravitational component because we're not measuring how fast or slow, how gravity affects your velocity. Okay, just to be clear.
How long would it take to cover the mile, Gary?
1/10 of the time. If you're going 10 times faster, it's 1/10 of the time.
Well, he would cover this distance in 1/10 of the time, wouldn't he?
Yes.
Because it's 10 times quicker.
Yes.
And in the same hour, he would go 10 times.
In the same hour. So the other thing traveled an hour here, you said. This was 1 hour at 1 mile at 1 mile per hour, and that's what you said this was. This distance here is 1 mile. So obviously, yes, if it's going 10 miles an hour, it's going to travel 10 miles. I mean, yes, it's going to travel 10 miles. It's in 1 hour.
Times as far. He
Yes.
would cover 10 miles.
Yes, it would. So it would go through the paint sprayer much faster. So only 10 minutes for this whole time here. So this one was in it for an hour. It's less than 10 minutes, right? 6 minutes, 7 minutes. So in 7 minutes, it would cover this whole thing. All right. And where this was in it for an hour. So this was sitting in it for an hour. The faster cars, I'm going to be sitting in it for 7 minutes. And so how much paint do you think is going to get on it? The sprayer is spraying. The one thing's sitting in the paint sprayer for an hour. The other thing's only sitting in it for 7 minutes. I think it's going to get 1/10 the amount of paint on it.
Not, as you say, 100 miles.
I'm talking about, clearly, all of my examples were just talking about rolling something that has energy. And we're trying to figure out how the energy is pulled out of it. So the whole experiment was about friction not being linear, and so of course nothing had a constant velocity because it isn't a useful argument. It doesn't mean anything. There's no quadratic component to distance anymore. Twice the velocity is twice the distance now, you idiot. Your kinetic energy theory doesn't play a role at all. Idiot.
As you did with the bucket. I have absolutely no idea where you're coming from at all. At all.
So he doesn't understand the difference between 7 minutes and 1 hour. So I'm in this 7 minutes, or 6 minutes, right? That would make it easy. 6 minutes, 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 6 minutes. That's the 1 hour. I've been in 1 hour worth of paint. And you don't understand that when it's only 6 minutes compared to an hour, that I only got 1/10 as much paint on me. The other thing was going 60 minutes in 1 unit of space. I only spent 6 minutes in that unit of space. So clearly I only got 1/10 the paint on me here, and 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 1/10 the paint on me here, 1/10 the paint on me here, 1/10 the paint on me here, and 1/10 the paint on me here. What about that can't you understand? Again, I mean, what, an 11-year-old? I could go to a 9-year-old could get this. They can count to 10 and figure out that, oh yeah, if I could do all kinds of different ways to example this. I could say, Let's shade it in really dark for how much time it's in this unit of distance, and I could just shade it really light when it's only 6 minutes. So 60 seconds would be dark, and then 6 minutes would be light and light and light and light, and then you'd add up all the light things. I could just put sixes here, right? I could just draw a 6, 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 and I could say, how much is 6 times 10? And he'll say 60. 60! Right? And I'll say, well, how much is it for that car that sat there for a whole hour? How many minutes is that? 60! You see? But you can't do it. Fuck.
It's such a simple thing for me. If he's going 1 mile an hour and we go 10 times as fast, he'll cover 10 miles in the same hour, won't he?
Yeah. And you'll do it much faster. So if it's raining, you're not going to get as wet per mile. You're going to get a lot less wet. 1/10 as wet per mile.
Let's say the car is a cabriolet. It's got an open top and he's collecting the rain as he's moving along.
That's so stupid.
If he collects 10 drops in covering the mile, if he now goes 10 times as fast across that mile, you could...
So what are you going to say except, oh, then he's only going to get 1 drop per mile?
say, well, he'll only have time to collect 1 drop, say.
There you go. You got the right answer. Now we're done.
But because in that same time, going 10 times as fast, he's covered 10 times the distance, and each mile he'd collect another drop.
Yeah, 1 drop. That's right. So where's the surprise? Sorry. I'm the one who's saying the same time equals the same force. You're the one saying the distance means you got more force. 10 times more force in this case. Sorry, I don't think you're winning.
So at the end of the track, he'd have the same amount of rain in it as if he was going 10 times slower at 1 mile an hour.
Same time equals same amount. Yes. Same distance equals same amount. No.
Exactly the same argument with the bucket.
Can anyone understand what he is saying here, right? He's just perfectly illustrated my point and pointed out, yes, that's exactly how it works. The time seems to completely be in control. The amount of time you're exposed to the sun decides how much suntan you get. The amount of time you walk in the rain decides how wet you get. The amount of time you hold your bucket in the snow decides how much snow gets in your bucket. Yeah, so he's completely agreeing now.
The point is, if we can't agree on reality, then nobody's going to be able to convince you.
Alright, so this is so dishonest, right? So I've been doing this for 2 years. I even made these little 5-minute videos, just made the argument so simple, and this motherfucker is going to pretend that there's some confusion about my points or what I'm arguing. No confusion at all. There's just I mean, again, I have drawn it 200 times. It's just a literal fact. 200 fucking times. Well, it's probably 163, but whatever. And this fucker is going to pretend that I'm making some different argument, or this argument is confusing, or it's not entirely decisive. Yes, it's decisive argument, and you haven't dented it, you haven't touched it, you haven't come anywhere near it, you fucking lying sack of shit.
Arguments. I mean, you made a big thing about the square.
Oh, no, don't get into this crap. This squared velocity crap. Let's pretend velocity is a volume of something. It's not a volume of anything, okay? It's just not. Time isn't anything real. You can't have an amount of it or any of this other crap. Alright, and so velocity isn't made out of something called an acceleration. It's just velocity. It's an arrow pointing in a direction. Period. It has a length. It's its magnitude. That's it. It's not a dimensional object. It doesn't have any other character. It's a line in a direction.
What's the square got to do with the, anything? You want to know the area of your floor.
So again, he's just going to keep preaching some theory that a velocity is made out of apple pie times ice cream. And it's not. It's not made out of something. It's a thing in and of itself, and that thing is simply one-dimensional. It's only a one-dimensional object. You can only have a velocity in one dimension.
In your house, you want to know how much flooring to buy. So you want to calculate the area of the floor.
Yes, and areas have to do with 3 dimensions or 2 dimensions, but they don't have anything to do with one-dimensional objects.
So you have times the breadth times the depth. 2 sides of the square. You multiply them together, gives you the area of the square, doesn't it? That's a practical application of it.
You can say it is, okay, and I'm just going to keep saying, why bother with that? I mean, it is true that distance and time, okay, will get you a line. That's your velocity. But it has nothing to do, again, with any dimensionality. There is no way to square that. It's a line. Your velocity is a line. It is not a volume. It's clearly not half of a volume.
And I was pointing that out because if you can't follow that simple logic, what's the point in arguing?
Exactly. Okay, that's fine with me. All right. I don't think there's anything logical about it at all. For you to claim that a velocity is a 3-dimensional object, that's, in my opinion, absolute fucking crap. All right. So if you want to claim that, fine. You claim that under, beneath the planet of the apes that you are. All right. But I'm not playing that. Homie, don't play that. It's not an argument. You want to argue it? Fine. You want to try to convince somebody with it? Fine. I'll just keep drawing Galilean reality, okay, that defeats you entirely.
Complex matters. So, as I suspect, you're beyond trying to reason with. If you can't agree with this,
you're also beyond, okay, the planet of the flat earthers. Yeah, I'll use both, beneath and beyond. You're both of those, bad plots.
And I think you can't agree with this because it disproves your bloody gravity theory.
Okay, so what did I disagree with? Disagree with what? So where did I disagree? No, he just agreed with me entirely that time decides how much is in the bucket. He agrees that it went 10 times as far in the same time. So, and it has the same amount of stuff in it. So obviously distance didn't have a damn thing to do with it. Alright. I mean, just too stupid. Too fucking stupid. You've been chewing too many fucking metal pencils. Retard. Sucking on erasers. I knew there was some cause for this lead poisoning he has. But anyway, I just can't believe this fucker. He's so dishonest. I mean, he's so fucking dishonest. I mean, again, I have drawn it so many times. Go ahead, assert that it isn't true. Just assert that it isn't true that when something's rolling, it's going to go half the speed when gravity's taking the force away. Okay, in gravitational friction, that it will be going half the speed 3/4 of its journey. Go ahead and say you don't believe that's true. Refute some fact that I've stated and point out how that actual fact that I actually stated is not true. You just basically diagrammed a huge straw man where you completely agreed with me and then claimed that somehow what you said is different than what I've been saying, that time is in control. And you just sit there and diagrammed how, yes, time is in control, and pretended you're telling me that, when no, that's what I've been asserting, retard. Oh, man, I just can't believe I can't believe that these creatures run free on this planet. Just people this fucking stupid can open their stupid fucking gobs and talk this shit. You know, title videos so incredibly dishonestly. He just should make a video saying, "Here I am making a fool of myself again." That's the appropriate title. Alright, till the next time and such. Fuck this.